clear, clear, clear. So we were so close to finishing yesterday with the parade or the trick-or-treaters coming through. We got very close to finishing. We talked about complex conjugates. We'll briefly go back over those here, because if A plus BI is the number we are given, its complex conjugate is A minus BI. If we're given A minus BI, its complex conjugate is A plus BI. So if we're given 3 minus 4i, its complex conjugate would be 3 plus 4i. If we were given 3 plus 4i, its complex conjugate is 3 minus 4i. All we're doing to get the we're changing the sign in front of I. Now this also means if I gave you 7i, focus up here, what would its complex conjugate be? Negative
2 plus 4i. The conjugate would be 2 minus 4i.
Sign in front of I.
Yeah.
So what would the complex conjugate of 6 be?
Well, it's just 6 because it doesn't have I.
Because we could say it's 6 plus 0i. So its complex conjugate would be 6 minus 0i, but the plus 0i and minus 0i just... If we just have a real number, it just stays the same, because we're just changing the sign in front of the term with I. Since 6 doesn't have an I term, it's just 6. Or the conjugate root theorem. So that is our kind of A plus BI, A minus BI. Complex conjugates, yeah. But that's all it's talking about. Now the reason that we have it is because of this here. We want to simplify these fractions, these rational expressions, because we cannot have I in the bottom of a fraction. Because what this is telling us is that we actually have the square root of negative 1 in the bottom of a fraction. Focus up here. Now we went over this yesterday, but to simplify these here, when we do it by hand, we multiply the numerator and denominator of this fraction by its complex conjugate, the denominator's complex conjugate. So the denominator is 2 plus 3i. The conjugate would be 2 minus 3i. Its complex conjugate is 2 plus. So we have 2 plus 3i. Its complex conjugate is 2 minus 3i. Now, I know a few of you weren't here yesterday, so we're going to actually multiply this out. Now, this is not changing the fraction itself, because 2 plus 3i, or sorry, 2 minus 3i divided by 2 minus 3i. What is that really? Anything divided by itself is? It's not 0. 1. Anything divided by itself is 1, yes? So really, we're multiplying this fraction by a fancy version of 1. Whenever we multiply a number by 1, it doesn't change the number itself. So this here is just changing how it looks. Now when we distribute for the denominator, 2 times 2 gives us 4. 2 times negative 3i is negative 6i. 3i times 2 is plus 6i. And 3i times negative 3i is negative 9i squared. We're going to do the same thing with the numerator. 1 times 2 is 2. 1 times negative 3i is negative 3i.
Oh, it is? Oh.
We'll do the same thing with our negative 4i, and then we will simplify. Negative 4i times 2 is negative 8i. And negative 4i times negative 3i is going to be plus I squared, because our negative times a negative would make a positive. 4 times 3 is 12, and I times I is I squared.
Oh, I was so stuck on it. Yeah, my bad.
Now, when we simplify the numerator, we still have 2, because there is no like terms at the moment with 2, but our negative 3i and negative 8i make negative 11i plus 12. Now, I squared is negative 1, because I is the square root of negative 1, and whenever we square it, it goes back to negative 1. I squared is negative 1. So instead of 12 times I squared, we really have 12 times negative 1. Anytime we have I to a power, an exponent, we do need to simplify it. Now the denominator, 4 does not have any like terms. Our negative 6i plus 6i is 0. So those are gone. Minus 9. And as we just said with the numerator, I squared is negative 1. So do we have I left in the denominator? Because the middle terms with I are 6 and negative 6 canceled out, and the I squared term becomes negative 1. That is the nice thing with multiplying conjugates together, complex conjugates.
I need Amy Robinette and Lori Martinez to report to this program at this time. Amy Robinette and Lori Martinez go to this program. Thank you.
Now our 12 times negative 1 would be negative 12. So we'll move those two together, 2 and negative 12. And our 2 minus 12 is 10 plus 11i. Our 4 plus 9 is 13. So this is this complex expression in standard form. Now, we can technically split it apart into 2 fractions. And we could say 10 over 13 plus 11 over 13i. Either one of these is the correct answer. Mr. McClendon. We're going over new material. Okay. You're welcome. Bye. Okay. Questions on this here? So this is how one way we can do these. Now, another way is we can actually do these in the calculator. However, the 30 or the 84 plus calculators that we have do not like these in fractional form. So we can't use alpha y equals enter and type it in as we see it. We do have to change it a little bit, because fractions is just another way to say division, or another way to write division, because we're just saying the numerator divided by the denominator, top of the fraction divided by the bottom, because 4/5 is just one way to write 4 divided by 5. So if we want to type this into the graphing calculator, 2 plus 5i, so we can say parentheses 2 plus 5i divided by 4i. And yes, you will need to put the parentheses around the numerator and around the denominator. Second decimal. And we get this here. Now we don't want to leave it in decimal form. We will need to write it in fractional form. And to get it in fractions, once we get that, we'll hit math, enter, enter. So the answer for this one here is 5/4 minus 1/2 I. Math, enter, enter. Questions on this here? We're going to look at one more, especially with the calculator here. So we have 1 plus 4i divided by 2 minus 3i. So to type it into the calculator, we're going to type it in as 1 plus 4i divided by 2 minus 3i. So 1 plus 4i divided by 2 minus 3i. So when you do hit enter, you do get these numbers here. Because again, it's converting it to decimal form, not fractional form. Math, enter, enter. I mean, really, I could have done this here and then went math and told it to go straight to it. But other than that, not really, because it would have to, you'd have to go into the mode to get there. And at that point, there's a good chance you're not going to just convert everything to fractional form. So instead of it saying that it's 2, it'll say 2 over 1. But that's just a guess. Negative 10 thirteenths plus 11 thirteenths I. Yes. Now the 30X or the TI-84 plus CE, the color edition, does allow us to use straight calculators. I am slowly trying to work on getting more of them, but it takes time. I mean, just short of writing a massive size grant, it'll take a while. One of the professional developments we went to gave us the license to be able to use the digital version. Can I borrow? Yeah. This is what it is physically. Yes, because they're a little bit newer. Questions on this here? We feel comfortable with this here. If you weren't here, I mean, all that you missed yesterday was, for those who weren't here, was finding complex conjugate and multiplying them together. Yes. Mm-hmm. Huh? Alpha y equals enter.
Dang it!
Four. So, on the first page of the worksheet, 1 through 5, find the complex conjugate and then find their product. So you'll find out what the complex conjugate is, and then you'd multiply the two together to find the product. So 1 through 5 does have 2 answers. 6 through 10 is the division. For this one, 10 points. Because most of the homework assignments are 1 point a problem. There's very few that are worth more than that. Because it has to have like 3 or 4 different parts to it. To where the systems of equations where you had to have 3 values for x, y, z, I made those 2 points. Or if there's 2 parts to the answer, or it becomes more complex, I'll normally do 2. But I normally keep it about 1 point a problem. So 1 plus I is the first one. 1 minus I. Then you would multiply the 2 together.
1 times 4. So could I do that on this?
Mm-hmm. Yeah, you can multiply them in the calculator. Do 1 plus I times 1 minus I in the calculator. And it, yes, and it should give you 2. Or just 2. Because the complex conjugates, when we multiply them together, the i's will simplify out. Mm-hmm.
So then I just keep repeating that process.
Yeah, because 1 plus I parentheses 1 minus I.
Plus I 1 minus. Is that only when it's by itself?
That's the properties of complex conjugates.
So 5 minus I.
So 5 minus I.
5 minus I would be 5 plus I. So the i's would be as well.
So then you'd multiply, not add. So you do 5 plus I times 5 minus I.
I'm just gonna, I guess, math them out.
Yeah. Okay. Now, unfortunately, we need to go to 351, the other note sheet. All right, guys, let's get the other note sheet out. Three, 5, 1. The square root of a negative number property. The square root of a negative number property, if r is a positive number, then the square root of negative r is I times square root of r. So you can write this down, make a simple note. All this is saying is that if we take the square root of a negative number, the negative is going to come out as I. Then we can take the square root of whatever that number is. And we've done that already. We did that in 341. But it follows from this property, if I squared of r, if we square it, we will get back to our negative r, what we started with. This isn't anything radically new. It's just saying if we take the square root of a number, we get a simplified form. If we squared the simplified form, we get back to what we started with. They undo each other. That's all this is saying. So I wouldn't focus too much on this. This is stuff we've known for the most part already. If r is a positive number, then the square root of negative r, what we did in 341, we start talking with I. We get I square root of whatever the number is. And if we square I square root of r, we get back to negative r. Now, x squared plus 4 equals 0 is the first thing we're going to look at. And we want to solve this. This we can solve by the square root method. There is no middle term. So we can get x squared by itself, square root both sides, and get our answer. So for this here, the first thing we would do is subtract 4 from both sides, which will tell us that x squared is equal to guys. Now that the x squared term, the term being squared by itself, we can take the square root of both sides, because the square root of x squared is x is equal to plus or minus. Now previously, when we hit this point, we didn't have 4, but we had negative 5/2. We couldn't go any further, and we just said no real roots, because we weren't able to take the square root of negative 4. But since then, we know the square root of a negative number is going to come out as I. Anytime we take the square root of a negative, the negative part comes out as I. Yes, it's 2I, because the square root of 4 is 2. And since x is by itself, it means the solutions for x squared plus 4 equals 0. The values of x that will make this equation be 0 are 2i and negative 2i. We do have solutions. They're just not real numbers. We have 2i and negative 2i. Questions on this here? The next one that we have is 2x squared minus 11 equals negative 47. Again, square root method. We need to get the x squared term by itself. So the first thing we can do is add 11 to both sides. And if we add 11 to both sides, we get 2x squared negative 36. Is the x squared term by itself? So we need to divide both sides by 2. And if we divide both sides by 2, 2x squared divided by 2 is x squared. Negative 36 divided by 2 is negative 18. Questions on this so far? Now we can take the square root because x squared is by itself. So we'll take the square root of both sides. Square root of x squared is equal to plus or minus. We can plug the square root of negative 18 into the graphing calculator and see what it says. And it's going to give us a decimal number with I. It will give us the I because negative 18, the negative will come out as I. But 18 is not a perfect square. The 30xs, our little yellow calculators, can take second square root of 18. Square root of 18 is 3 square root of 2. So the square root of negative 18 is 3i square root of 2. So the solution for this problem is x is equal to plus or minus 3i square roots of 2. Questions on this here? Now we're going to do one more, and again, it's going to be by the square root method. Because the square root method is the only method that we have that will actually solve for these imaginary solutions, these solutions with I in them. It's the only one that works. Now for this here, 4x squared plus 20, we want to find the zeros. We want to see what value of x will make 4x plus 20 equal 0. So the first thing we're going to have to do is subtract 20 from both sides. So that tells us 4x squared is equal to negative 20. And we're going to divide both sides by 4. X squared is equal to negative 5. Yes. Then we would square root both sides. So we would have plus or minus. So we would have I, yes? That's square root of 2. Square root of 5. Because the only reason the others reduced, square root of 18 reduced is 3 square root of 3. Because 9 times, 3 square root of 2 for 18. Because 9 times 2 is 18. Square root of 9 is 3, so the 3 came out, 2 stayed in. Here, since 5 doesn't reduce at all, it just stays square root of 5. Questions on this here? Questions on any of those so far? Now, as I've already said, we've been using the square root method because since these have non-real answers, we're dealing with I, we have to use the square root method. It's the only one that works. And to use the square root method, we have only one or two setups that work. Either 1 we just have x squared, we don't have a middle term. Or the other case, the only place where x was inside of a set of parentheses being squared. Yes? Now, if we look at the next problem, we want to solve x squared minus 16x plus 64 equals 100 using square roots, the square root method. Now, there is something interesting with this problem here. I'm going to factor just this here, x squared minus 16x plus 64. We're not going to worry about the 100 yet because there is something interesting with this part of the problem. There is no greatest common factor, so we can move on to our two sets of parentheses with 3 spaces. A little bit, yes, but now we're putting I back in. And this is the introduction to the first method that actually works for any quadratic. Now, when we factor this here, two sets of parentheses with 3 spaces, we're going to find the signs. If the third term is positive, the signs are the same and match the sign of the middle term. So they're both going to be negative. Let me write. Negative and negative. Factors of the first and third term. Well, factors of x squared are, because 64, we will use 8 and 8. 1 and 64, 2 and 32, 3 doesn't work, 4, no, yes, 4 and 16, 5 doesn't work, 6 doesn't work, 8 and 8. So we will use 8 and 8. And if we did check this, we would get negative 8x minus 8x, which is negative 16x. Questions on this so far? This is odd because normally when we factor, we would move the 100 over and then try to factor from there, yes? But our two factors came out to x minus 8 and, yes? Is there any way I can rewrite something where I have two things that are, yes? Because we have two things being multiplied together, yes? But those two things are the exact same, yes? So another way I can write or say that something's being multiplied by itself is rewriting it as x minus 8. Wait, that means we can use the square root method, yes? As we do have a term being squared. Now, what's interesting is x squared minus 16x plus 64 is a special type of quadratic. We call it a perfect square trinomial because it can be rewritten as a set of parentheses squared. Because now that we have this, we can take the square root of both sides. Now on the left-hand side, the square root and square will cancel, leaving us with x minus 8 is equal to plus or minus square root of 100 is 10. Now x is not by itself. We need to add 8 to both sides. And just like we had before, we put the 8 in front of the plus or minus. Any questions on this here so far? Or combine them? Yeah. Now here we can combine them. Because the 8 and 10, are they like terms? Yeah. So what we have is two different statements. To do that have x is equal to 8 plus 10. So here, 8 plus 10 is indeed 18. Yeah. we only have to write both of them out if they are like terms, if we can simplify them. Here, we can do 8 plus 10 is 18. We can do 8 minus 10 is negative 2, yes? Because they are like terms, we can simplify them because the solutions are 18 and negative 2. Now, I'm going to change it just for a second. If I said 8 plus or minus 10i, are those like terms? No. So then our solution is x is equal to 8 plus or minus 10i. Because we could technically split those into two statements. X is equal to 8 plus 10i, x is equal to 8 minus 10i. But that's as far as they go. We can't put them together. I split them apart here because, one further. We can do 8 plus 10. We can do 8 minus 10. We can actually do those two calculations. So I split them apart for myself to be able to see them, then do the addition subtraction, and we're done. Does that make sense? If we can combine them with addition subtraction, we will combine them. If we can't, we leave it with the plus and minus. In the two cases, well, technically three, that we would leave it with the plus or minus is if one of the terms has I, a square root that's not simplifiable, or both. One of the terms has both a square root and I. So like earlier where we had 3i square root of 2, we'd leave it because even if we had a number in front of it, we can't combine those two. Questions on this here? Questions on anything we've done so far? Now, what would be nice is if every quadratic was a perfect square trinomial. We had something like this for every single one. Because if we had that, we could rewrite it as a set of parentheses squared and use the square root method. Because that would be nice, yes? That is the first method we will learn on solving any quadratic. And the method is called completing the square. Completing the square, turning the quadratic into a perfect square trinomial, into one that we can turn into a set of parentheses squared. Now the first step in doing completing the square is making a perfect square trinomial. Now we do have this on the note sheets, the x squared plus 14x plus c. So, yes. Now, to find c, to make this a perfect square trinomial, c is defined to be b over 2 squared. So this c term, to make this into a perfect square trinomial, to make it into a case where we can rewrite it as a set of parentheses squared, our c term is b over 2 squared. And we're going off of our ax squared plus bx plus c. So we have our x squared plus 14x plus c. You don't have to rewrite it because you do have it there. Now for us in this case, a is 1, b is 14, and we need to find c. So to find c, b over 2 squared. Our b term in this case is 14. Well, what is 14 divided by 2? Well, our 14 divided by 2 is 7. 7 squared is 49. So our perfect square trinomial is x squared plus 14x plus 49. That is our perfect square trinomial. And having this almost, and we want to express this as a binomial squared in factored form. Now what's interesting with this here, with completing the square method, when we factor it down to a set of parentheses squared, we'll have the set of parentheses, we will have x, but the number that goes in here and its sign will match whatever the number that we have in trying to solve for c before we square it. So here we have positive 7, yes? So the number that goes inside the parentheses would be plus 7. If the number had been negative 7 before we squared it, we would plug it in as minus 7. So for right now, this is the answer. Because this is the keystone to completing the square. This is the main step. This is the most important piece to completing the square. Is this right here? Questions on this here? We're going to do one more. I want to look at number 5. Well, no, I can't get ahead of myself. Let's look at number 4. Yes. So number 4, we want to find the value of c and then rewrite it as a set of parentheses squared. So our value b is 8. 8 divided by 2 squared is... Now we could type the whole thing into the calculator, but it's good to take at least the division of 2 first. Because 8 divided by 2 is 4. 4 squared is 16. So our perfect square trinomial would be x squared plus 8x plus 16. Now if we rewrote it in factored form, yes, our set of parentheses squared are x. The number that goes in here is whatever we had inside the parentheses before we squared it. Positive 4. So it's plus 4 squared. Questions on this here? I know the bell's about to ring in a second. Let's stick with me long enough to finish this one. So, x squared minus 2x plus c. Now again, the value b is what? Negative 2 over 2 squared. If the value b has a negative, a minus sign in front of it, we take the sign with it. Sign's a part of it. Now our negative 2 divided by 2 is negative 1 squared, and negative 1 squared is 1. So what that tells us not quite, because x squared minus 2x plus 1 is the perfect square trinomial. C, the value of c for any of these here is going to be positive, because when we square a number, it's always going to be positive. Now when we factor it, the number that goes in there with x is whatever the number that we had before we squared it. In this case, it is negative 1. So we have x minus 1 squared. Questions on this here? Actually, we do. I misread my watch. We do have time for one more.
No. Okay.
And I want to get to this one purely because of the middle term. So c is equal to, because we need that c value to make this a perfect square trinomial, yes? And the b value that we need is negative 9. So c for us here is equal to b over 2 squared. Well, b is negative 9, yes? What is negative 9 divided by 2? Does it divide evenly? Does it reduce at all? No, not without turning it into a decimal, yes? So hang on for a second. We're still here. Leave it. If it does reduce, if we had negative 18 over 2 or negative 18 over 4 and it reduced to negative 9/2, leave it as a fraction. Because what we're going to do next is we're going to square it. And when we square it, we get 81 over, which tells us this here is x squared minus 9x plus 81 over 4. And in factored form, we plug the other half of it is whatever we have inside the parentheses before we squared it, which in this case was. So we get this x minus 9 over 2. Questions on this here? Okay, now we will get more into completing the square tomorrow. I'm giving you this assignment because 3 and 5, if you do start it and get confused on those, that's fine. But 11 through 18 is finding the value of c. So finding that perfect square trinomial and then factoring it. That I know that y'all can do. If you do have questions, please let me know.